Next.
Sir, in
Uh,
this U and V are related, no, sir.
U and V are related.
In this function, so Jacobian should be zero, no, sir.
U and V related means uh, independent, or if U and V are independent, that means what is the formula of independence? That is, there exists constant. There exists constant C, or C1 and C2. What is the if U and V are dependent, that means there exists a constant C and C1 and C2. C1 V1 plus C2 V2 is equal to 0. If C1 equal to 0 and C2 equal to 0, then V, that is U and V. U and V. If C1 equal to 0 and C2 equal to 0, then we can say that U and V are independent. If C1 and C2 are not equal to 0, then U and V are dependent. But here, but, but, but here in the function f1, there is a variable xy. So we can't say that U and V are dependent because there is variable x and y. If if there is if x and y are constant, then we can say that U and V are dependent. Okay. Partial derivative of implicit functions by Jacobians. There is two function x, y, u, v is equal to 0, and f2 x, y, uh, u, v 0. In that case, U and V will be dependent when? If there is a function, suppose f C1, C2, UV is equal to 0. In that case, we can say, we say that U and V are dependent, right? But here there exist variable x and y. In that case, we say UV are dependent. So partial derivative of u with respect to x, this will be del f1 f2 by del xv by del f1 f2 with respect to uv minus. So del u del x equal to Jacobians of f1 f2 with respect to xv by Jacobians of f1 f2 with respect to uv. Similarly, del v del x del v del x will be minus of del f1 f2 x u by del f1 f2 by del vu. For the three function, case of three function u, v, w and x, y, z variable, in that case del u del x, this will be del f1 f2 f3 with respect to del x, y, z. First we find del u, del x, del y. Del x y, z, del f1 f2 f3 u, this will be x, y, z now, x, v, w, and this will be u, v, w. Let an example. Find del u del x. If u square plus x v square minus xy is equal to 0 and u square plus x y v plus v square equal to 0. So here first function f1 is equal to u square plus x v square minus xy, and second function f2 is u square plus xy v plus v square. So Jacobians of f1 f2 with respect to uv, this will be formula del f1 del u del f1 del v del f2 del u del f2 del v. This will be 2u 2x v and 2u xy plus 2v. The value will be 2uxy.
So it is
Plus-
supposed to be x and v, right?
Hello, bolo.
It is del of f1 f2 by del of x and v, right?
Del of del f1 del u uv. First we find uv or Jacobians of f1
Okay, sir, yeah.
f2
Okay.
with respect to uv. For uv minus 4uxv. Now find Jacobians f1 f2 with respect to xv. So del f1 del x, del f1 del v, del f2 del x, del f2 del v. So this will be v square minus y 2xv del f2 by del x yv and del f2 by del v. This will be xy plus 2v. This is calculating, we get minus xy v square plus 2vq minus xy square minus 2yv. Now what is the del u del x? Del u del x, this formula is the Jacobians of f1 f2 with respect to xb Jacobians of f1 f2 by with respect to uv. So this is del u del x. So just put the value, that is, and there is a minus before this. So minus of, so this will be minus of x minus xy v square 2v cube xy square minus 2yv by 2uxy plus 4uv minus 4uxv. Just put the value. This is our partial derivative. ओके, ठीक है, आज का क्लास यही था. ठीक है, थैंक यू.
Thank you, sir.
Thank you, sir.